before we start, can I invite everybody to turn their mobile devices to silent? Okay. Today we have Dr. Sachin Vinayak Jangam from the NUS College of Design and Engineering to speak on his topic, Energy Systems and the Environment, Powering the Green Economy. We'll also be having a question and answer session right after this talk. For those who are tuning in online, you can type in your questions into the chat box next to the video. Be sure to enter your questions into the correct chat box for the correct tract. For those who are here in person with us, you can choose to scan the QR code as well to ask your questions, or you can walk to the middle of the room and ask your questions directly into the mic. So now, without further ado, please help me to welcome our speaker, Dr. Sachin. Doctor, please.
Thank you for your kind introduction. Good afternoon, everyone. Thanks for coming on Saturday. My name is Sachin, as my colleague just mentioned. I'm a senior lecturer in the Department of Chemical and Biomolecular Engineering, and I'm the co-director for MSc Energy Systems program. So let me start my talk with the first slide. I think my colleagues must have talked about NUS. I don't want to spend time on this. We have 35 minutes, so I would like to utilize 35 minutes as best as possible. So let me not go through these statistics about NUS, which we can easily find from NUS website. I would certainly like to talk about a little bit about our department, the Chemical and Biomolecular Engineering department. Let me quickly mention the vision. Our vision is to be a world-leading academic program in chemical engineering education and innovation. That's our vision. And our mission is to nurture creative chemical engineer leaders and innovate for a sustainable future. So our mission itself has something about sustainability. All right. In our department, we have about 798 undergraduate students, about 507 graduate students, and these are the number of BEng students, MSc degree students, and other postgraduate students who graduated recently. As you can see, we have 35 tenure track faculty members, a very substantial and broad area of research in our department. We have 9 practice track and educator track faculty members in our department who solely focus on education, basically just teaching and related research. We have 8 emeritus professors and honorary fellows, 7 adjunct staff, and several research staff, laboratory staff, and admin staff to help with our departmental activities. Let us move on. We offer, of course, undergraduate degree, BEng in chemical engineering with 3 specializations: biopharma, process systems engineering, and safety and sustainability. We also offer minors in several topics, but the key topics are mentioned here. We also offer part-time engineering program, which is a BTech program run by Scale, our department. Okay. Then, coming to the MSc programs, we offer 3 MSc programs. The first one is chemical engineering. Second one is safety, health, and environmental technology. And the third one, which I'm going to focus a bit more about, right, is MSc Energy Systems for today's talk. Let's get on with our technical stuff now, right? Why we are even discussing a particular topic that I've selected for today's interaction. Well, since the Industrial Revolution, these statistics are available, on website, any website. Just Google search, you can get these numbers, okay? Rough numbers. So the population has increased. The population has increased from 0.7 billion to about 7.8 billion, which is a substantial change. The global GDP has risen, and when the GDP, the growth increases, right, that will result in more and more energy consumption. So the energy consumption has increased from 5.6K terawatt hours to 159K, which is a substantial rise in energy consumption. And when there is an increase in energy consumption, it has direct effect on environmental impact, isn't it? So we have atmospheric CO2 risen from 280 ppm to up to 420 ppm. And CO2 emissions have risen from nearly zero to 37 billions of tons. That's a substantial increase in carbon footprint. Okay? Of course, all these things have, I'm sorry. Okay. Is it okay? I'm sorry. Now, as we all know, all of this has a negative impact on the environment, right? Rising sea levels. Isn't that correct? It's a main concern that all of us know. Or glaciers, which continue to melt, is another important issue that humankind is facing. Just to appreciate the importance of this, right, let's look at some more statistics now. Well, the worldwide energy consumption has been on a rise, except a bit of a drop, right? Thanks to COVID-19, right? The energy consumption reduced a little bit, then again it is rising, okay? So this is a simple slide showing the energy statistics on energy consumption. Again, this slide shows some of the statistics based on the source of fuel that we use. Almost for every fuel that we use, the amount of energy consumption is on a rise. If you look at coal, oil, natural gas, electricity, almost everything is increasing, except, again, as I said, a bit of a dip in 2020, which is a result of COVID-19. Okay? So this slide is just to make you understand and appreciate the importance of use of energy, right, and its direct impact on the environment. Let's look at the Singapore context, right? Again, in Singapore, there has been some impact of COVID-19, and the total final energy consumption has reduced a little bit in 2020 compared to 2019, but again, it will be on the rise for sure. Okay. Now, what exactly happens when we use more and more energy? Of course, it will have environmental impact, and one of the most important thing, as all of us know, is global warming. Now, almost every one of us knows the term global warming, so I don't have to explain that in detail, right? So I won't spend more time on this. All of us have learned this in secondary school, or some of those who went to JC, or those who went to poly. All of you know about global warming. So this is the most common and serious consequence as a result of industrial pollution. What happens exactly? So pollutants from a small area, they accumulate and spread in the upper atmosphere. And that affects the entire Earth's weather. In other words, a global effect. And that's why the term came in, right? The global warming. So emission of various greenhouse gases resulting in increase of Earth's temperature is the basic concept behind global warming, right? Now, what exactly is greenhouse effect? Well, all of us know that CO2 is transparent to visible light, but it is efficient in absorbing infrared heat radiation, okay, emitted by Earth's warm surface. So it traps heat in the air close to the Earth's surface, and it re-emits back to the Earth, which is the reason why the temperature has been on a rise, okay? What is the impact? All of us know the impact is vast changes in weather patterns, glacier melting, as I mentioned before, shrinkage of polar and mountain ice, hurricanes, and so on and so forth. So there are several impacts of use of energy indirectly on the environment, right? And as I mentioned, sea level rise in this century is about 4 to 8 inches, which is something to really worry about, right? This again another slide showing a bit more about global warming. Greenhouse gases or its effect depend on several factors. So the concentration, residence time of various gases in the atmosphere, and how strongly it absorbs the radiations. So typically, the global warming potential is a measure of the total energy a gas can absorb over a particular time compared to CO2. So if at all we want to quantify the effect of, let's say, methane, right? We don't typically do it in terms of methane. Typically, we find out what is the CO2 equivalent emission of methane, for example, right? That's a very simple concept. Some of you might already be knowing this, okay? So finally, the bottom line is we have to look at the CO2 emissions, right? So this slide shows the industries, various industries responsible for CO2 emissions, right from energy industries to agriculture sector, typical, traditional industries, transportation, buildings and waste, almost everything has an impact on environment. Specifically, energy has much bigger impact, right? So we have to worry about this. Let's look at another slide showing some more statistics. If you look at world CO2 emission by fuel in 2014, electricity and heat contributes to 42%. Industries contribute to 19%. And out of this 42%, industries are using about 18%. So almost 37% is a direct contribution of industries. So this is again something that we as engineers, I'm a chemical engineer, hardcore chemical engineer, so we always think about this. Again, some more statistics. So these statistics shows us the importance of reducing CO2 emissions. The other important thing that we need to worry about is the depletion of ozone layer. So what is exactly ozone layer? Well, ozone layer is something that keeps 95 to 99% of sun's UV radiations from striking the earth. As again, all of us have learned this, right? Either in secondary school or higher education. How ozone absorbs UV radiations? It's very simple. The ozone absorbs ultraviolet light and it gets split into oxygen molecule and oxygen radical. And then this oxygen radical will recombine and oxygen molecule allows ozone to be formed. Okay? So this is a simple chemical reaction that will help you understand how the UV radiations are absorbed. However, there has been a slow and steady depletion of ozone in the Earth's stratosphere. Just look at these numbers. 1% loss of ozone is equivalent to almost 2% increase in UV radiations. And this effect is known as ozone thinning or ozone hole. And who are responsible? What chemicals are responsible? Mainly hydrofluorocarbons or chlorofluorocarbons. And what are these? These were the traditional refrigerants, right, that humankind has been using. Okay. Now, what is the impact of all of this? I don't want to go through this chemistry here. The impact is human health is a major impact of ozone thinning, reduced crop yield, disrupted aquatic food chain. So we have to worry seriously about ozone depletion as well. Of course, humankind has been taking some steps to reduce that effect, and Montreal Protocol on substances that deplete ozone layer is one of that example, right? So I think most of us know that we have reduced the use of chlorofluorocarbons or hydrofluorocarbons, Now that brings me to a definition of sustainability. What exactly is sustainability, right? Well, there is no unique definition of sustainability, to be honest. But sustainable development is the one that meets the needs of present without compromising the ability of our future generations to meet their own needs. That's a simple definition. But of course, there are several other definitions of sustainability available. Now, we as a chemical engineer, of course, when I talk about myself, I will always refer to me as a chemical engineer, right? But of course, there will be some people from other engineering fields as well. But we as engineers, what we do or what we strive, we always strive for sustainable manufacturing through economically sound processes that will minimize the negative impact on the environment. That's a simple idea as we engineers look for, right? And for this, to understand whether our process or manufacturing is sustainable or not, we use some kind of indicators. We call them as sustainability indicators or metrics. Okay? So we need some guidelines, right? Isn't that correct? Otherwise, we can't just say, oh, I reduced my energy consumption by so and so, my process is sustainable. No, there is no unique definition as such, right? So what we do, we use certain indicators to assess the environmental performance of our process, and then we try to compare year by year, right? And then we track how our process is improving or becoming more and more sustainable. Okay? It is very important to understand and explore energy savings opportunities. My colleague who was just presenting before me was talking about reducing the energy consumption, right? So when it comes to sustainability, we always talk about use of solar energy or other renewable energy sources. But of course, it's not very easy to quickly move from the existing energy resources to renewable energy resources, right? So the first thing we as humankind do is try to understand and explore how we can save energy, okay? And then explore possibility of using renewable energy sources, all right? Now, for engineers, specifically again for chemical engineers, of course, there are certain guidelines available. So if we go to Institution of Chemical Engineers website, we can get some suggestions on what kind of sustainability indicators one can use to track the performance of your process. Okay? More on sustainability metrics, what exactly are these? Most of the metrics are calculated in the form of appropriate ratios. For example, environmental metrics. So what is the environmental impact per unit of product I'm producing? So let's say I'm producing product A. What amount of energy I'm using per kg of A that I produce? Either per year or maybe per month, whatever unit you choose, right? How do we use these metrics or indicators? I mentioned before already, we use this to track the performance of our process. We don't have anything ideal, right, to compare with. Isn't that correct? So we always use these metrics to track the performance of our process over the years. So it provides a tool for engineers to assess the operation that they're working with. It helps companies to set energy targets and other targets and develop standards for internal benchmarking. So don't feel that, oh, I'm using so and so amount of energy, so my process is sustainable. Absolutely not, right? Because energy requirement for every process may differ. Isn't that correct? And it helps to monitor progress over the years towards sustainable development. Of course, there are other indicators as well other than what I flashed before, but these are some of the indicators. Now let's come back again to Singapore context, right? We are in Singapore. Our university is in Singapore, so we always strive to do something that will help our country. Isn't that correct? So for us, what are the threats? As I mentioned before, rising sea level is one of the threats. Isn't that correct? And what are the key steps? Of course, we have been taking a lot of important steps, right? All of us know about Singapore Green Plan. What is the goal? The goal is to halve CO2 emissions by 2030 and net zero by 2050. Okay, and what are the measures, other measures we are taking? Carbon tax and carbon credit is one of the idea, right, that we have been using, and which is the key driving force for industries to look at their processes and reduce the energy consumption and carbon footprint. And remember, currently, the current tax is substantially low, but it's going to go up quickly. So every industry, every organization has to look at their energy consumption and try to do something, right? Try to tweak their processes so that they can reduce the energy consumption. Let's move on. What are the other driving forces, right, for us to take our MSc course? Isn't that correct? Well, all of us know about something called as the Sustainable Development Goals, which were adopted by United Nations members in 2015. So there are 17 Sustainable Development Goals, out of which the two most important goals which I would like to flash today are number 7, which is affordable and clean energy, and number 13, which is climate action. Okay? Let's look at number 7 and what are the targets for this particular sustainable development goal. So it says, ensure access to affordable, reliable, sustainable, and modern energy for all. And what are specific targets? So by 2030, we need to ensure universal access to affordable, reliable, and modern energy services, increase substantially the share of renewable energy, and double the global rate of improvement in energy efficiency. And of course, there are other targets, but these three basically covers most of the sustainability aspect, right? Now, where we stand, there are several challenges. Almost 1 in 5 people still lack access to modern electricity, and we are not very far from 2030, right? Every year, indoor air pollution kills 4.3 million people, and energy provided by fossil fuels is still the main contributor of climate change. Of course, in Singapore, most of the energy is produced using natural gas, right? But in other countries, still coal is used, which has a substantial carbon footprint. Again, some more challenges. There had been impressive progress in electrification, which my colleague was talking about, right? Electrification in the previous talk, but it has slowed down. And international financial flows to developing countries for renewables has declined for a second year in a row. So these are the things we should be worried about, right? If we want to achieve these sustainable goals. What SDG 13 tells us? The main thing is take urgent action to combat climate change and its impact. And our program covers majority of things that are needed to address these issues as engineers, or even if you are from non-engineering background. Okay? Let's talk about it a bit later, okay? Now the problem is all these sustainable development goals are interlinked. What do we mean by that? That means if I try to achieve one goal, I'm not able to achieve the other goal. So there is always a conflict, of course. So there are synergies. That means if one sustainability development goal is achieved, maybe I can achieve another goal. But there is also a trade-off. That means a negative linkage. That's why it's very difficult to achieve everything. Okay? What are the key measures needed, right? Of course, reduce coal usage. There is no second thought. Increase use of renewable energy sources. Improve energy efficiency, which is one of the major things that I focus in my research as well as in my teaching. Carbon taxes, which Singapore is already using. Subsidize energy efficient technologies, again, which is another measure we have here in Singapore. Carbon capture and storage, several of my colleagues are working on this topic. Okay? So we have several colleagues in our department and in our faculty, essentially College of Design and Engineering, who are addressing one or more than one of these issues, or majors rather, okay, not issues. In Singapore context, I already have mentioned about SG Green Plan and the carbon tax. And future of Singapore's energy story is that we have 4 switches to power Singapore's future, right? Natural gas, which we already have been using. Solar is going to be a major thing in Singapore, right? Because that's I would say the most appropriate renewable energy source for Singapore. Regional power grid and low carbon alternatives. So these are the 4 switches to power Singapore's future. Let me move to the next slide. In general, we as engineers would strive to move from fossil fuel based energy to any of these options. As I mentioned, solar or hydrogen or wind energy or low carbon alternatives, other low carbon alternatives. Of course, all of these are not possible for Singapore, but at least some of these are very relevant to us. Okay? Let's talk a little bit about solar energy. All of us know energy generated from natural resource, which can be replenished. As I mentioned before, this is the most viable option for Singapore. What are the benefits? Environmental sustainability requires no import of fuels and can reduce the peak demand. I won't say that we can completely replace, right, our energy demand with solar energy. What are the limitations? Limitations are physical size, that is the space availability, and intermittency. But still, we, being on an equator, right, we are at a benefit, right? Correct? So intermittency is certainly an issue, but not as much as maybe some other countries for us. And of course, solar photovoltaic systems. Now this is one of the image from Singapore, right? So I think some of you must have read this in Straits Times. What is the value chain? Typical steps involved in solar energy usage is production, generation, transmission, distribution of it, storage, and then house consumption. Okay, so this is a simple slide showing the value chain for solar energy. Again, some of these slides are just to show you use of solar energy and how Singapore is serious about this, how much serious we are about this. And certain news that have been published related to solar energy in local newspapers. The second energy source that I would like to talk about is hydrogen. This is a very high quality energy carrier which can be used with a very high energy efficiency and zero or net or near zero emissions at the point of use. Okay, that's the main thing. Remember this. Two basic process technologies. One is reformation of natural gas. The other one is electrolysis of water. What are the pros? Well, hydrogen is renewable. Of course, I put a question mark, right? Because some people still question whether it is really renewable. It is abundant, a clean fuel, non-toxic, and fuel conversion efficiency is higher than any other fuel. What are the cons, limitations? Currently an expensive fuel, and the other main challenge is transportation and storage. So safety is a bit of a concern, right, when it comes to hydrogen. Now, what are the sources, right, for hydrogen? So typically, hydrogen or type of hydrogen is divided as brown hydrogen, the hydrogen produced as a product of industrial processes, gray hydrogen, so hydrogen produced using fossil fuels, blue hydrogen, which is produced using fossil fuels, but CO2 is captured, and finally, green hydrogen, which most of us would like to target, right? But it's not that easy, which is hydrogen produced using electrolysis powered by renewable electricity or nuclear, which is zero carbon, source of hydrogen. But as I said, it's not that easy to completely switch to this green hydrogen. What are the other options? Wind energy, which can be harnessed day and night. Geothermal energy, so heat energy from within the earth is captured and harnessed. Of course, it may not be very relevant for Singapore. Biofuel, categorized based on the source for production, and also called as carbon neutral source of energy. So biofuel is another important thing that some of my colleagues are working on actually. Okay. Natural gas, as I mentioned before, this is environmentally clean alternative fuel which Singapore has already been using. There are certain safety issues for sure, but these are other options. Now, when it comes to our MSc Energy Systems program, you would get to understand many of these technology in greater detail. We have dedicated courses, let's say just for hydrogen energy, dedicated courses on green energy, okay, or energy systems, for example. Now, the other thing which I have been stressing on, right, is energy savings. So, of course, switching to renewable energy is one option, but it's not completely possible, right, on day one, right? So, what we can do, what is the first step we can take as engineers is save energy. So if you are a chemical engineer, you will love to know this. We can use a simple technology called pinch technology or known as heat integration technologies to recover energy within a process. So basically transferring heat from something which is hot to something which is cold, which otherwise we are wasting, right? So transfer energy, recover as much as possible and reduce the energy consumption. So you solve the problem automatically, isn't that correct? So pinch technology is very popular, very simple and systematic technology which one can use to analyze and minimize heating and cooling utility demands in a process. And this is also extended to other applications such as wastewater and cooling water minimization. Water is quite expensive in Singapore, right? Quite precious for us. So we can use similar technology, similar ideas and reduce water consumption in Singapore. Okay, or not in Singapore in general, in any process. Okay. So the idea, as I said here, is if you have a process stream which requires heat and you have another process stream which requires cooling, then you can simply transfer heat between these two process streams and minimize the use of external energy sources. That's the simple idea. It sounds simple on this slide, but when you try to put it in reality, of course, it's complex, but it can be done. So one should first strive to recover as much as energy and minimize the energy consumption, and then look at the renewable energy sources. Okay. As I mentioned before, this can be extended to various other applications such as reducing the cooling water consumption and reducing the wastewater in a process. Okay. So this is just a slide showing. Because I'm running out of time, I would like to just move on to other stuff. The other thing that is important and we teach in our curriculum is something called as the life cycle assessment. Okay, life cycle assessment is becoming an important thing, right? To understand what is the overall impact of your process, right? What exactly is life cycle analysis? It's a technique used to analyze the environmental impact resulting from all stages involved in product life cycle of anything that we buy. Take a tissue paper, right? What are the various steps involved? Right from, cutting the trees or planting the trees, cutting the trees, getting that paper out, fabricating it, and supplying it to user, and after user uses it, dispose it up. So entire life cycle, isn't that correct? So that's why it's known as cradle to grave assessment. Okay? So LCA studies range from highly detailed quantitative assessments to some qualitative assessments. And why do we do this? These are useful to identify trade-offs among alternatives. That means, let's say you have 3 different processes to produce something. Then you can do life cycle assessment and check which has the minimum impact on environment, right? And then you might want to go for that particular option. Okay? You can identify opportunities to improve systems, support environmental decision making, and achieve sustainable development. Okay? So LC also helps decision makers to select the product and process that result in least impact on the environment. So these are the 4 steps. I don't want to go into details. As I said, I'm running out of time. I just have 5 more minutes. So I'll try to go to the remaining slide to share a bit more about our program. Okay? So in summary, we just had an overview of reality check on climate impact at global level as well as at Singapore level. And we discussed what are the options available with us, which you can learn when you join our MSc program. So why energy systems program, right, that we have been offering? Well, traditionally, energy in engineering is taught as a single discipline. Okay, so you can see, for example, petroleum and gas in chemical engineering, thermal related energy in mechanical engineering, or energy transmission in electrical engineering. So we thought, like, why shouldn't we have a multidisciplinary and more holistic approach, right? Correct? That's why we came up with this program called Energy System. So we have Master of Science in Energy System offered by CDE, our department, and I'm one of the directors and my co-director is also here. Prof. Jian Wen is here to answer any questions that you may have later on. All right. So what are the goals? Our goal is to address the gap in current single disciplinary energy education, to equip with holistic and foundational knowledge in energy technology and innovation management. That's the key. And to facilitate decision making in energy solution and investment. And these are educational outcomes of our program. And let's quickly look at the program structure. So it's about 35 minutes. I should be able to finish it soon. Okay, Ryan? So we have first basket, which focuses solely on the technical side of energy or sustainability, right? You can see the courses that we offer: hydrogen energy and technology, future fuel options, carbon capture, modern power systems, solar energy systems, and so on. Completely technical list of courses. Then we have a second basket, which is cost analysis and engineering, economy, decision analysis, almost everything related to management or innovations. Okay? And finally, we have a third basket where we offer selected topics in energy systems as one course, and the other one is energy systems project, where you can work with a professor working on a particular topic of your interest, and you can do one project for 2 semesters, which is spread over a year. Okay, so you get an experience of doing something hands-on. That's not mandatory, but you can do that. And of course, there are several job perspectives. With that, I think I will stop here. Sorry to exceed by a minute. Again, thank you for this opportunity, and thank you all for coming and attending this sharing session. We are happy to take questions. Thank you so much, sir.
Your time and your expertise. So as Dr. Sachin mentioned, we'll move on to the question and answer segment. For those who are tuning in online, you will be able to submit your questions through the chat box. Otherwise, you may want to scan the QR code over here, or you may want to just go to the mic and shout out your questions. So maybe the first question we can ask: what are the career prospects for graduates of this program?
Well, of course, there are diverse. I mean, this particular program is quite diverse. You can get an opportunity in several industries, not just chemical and process industries, but various engineering industries. Almost every industry now require energy engineer. Okay, especially if their energy consumption is above certain threshold level, you need energy engineers. You need engineers to improve your process, right? Considering all these measures like carbon tax and all, industries will invest in moving from traditional energy sources to renewable energy sources. So definitely there are quite bright future prospects for MSc Energy System students. Again, there are other opportunities like government agencies where these graduates can go and work as well. So I hope I answered this question clearly or satisfactorily.
Okay, so the question is, are you working on bioenergy production? I believe the person asking is there a module or will the program touch on bioenergy production?
All right. So I'm not personally working on this. I mentioned there are colleagues who are working on this. So we have a couple of colleagues working in this particular area. We do not have a dedicated course for this, but we have a component of this included in a couple of courses. So there is no specialized module or course for this particular topic.
Okay, thank you, Dr. Sachin. So is there another question or maybe any questions from the floor about?
There is one flashed here, if you want to take it. I'm from a non-STEM background but working in a relevant industry. Still my profile be absolutely yes. So if you are from STEM background, you're welcome to come and apply for this program. And you should be able to cope up with it with a STEM background.
But what if someone is maybe not from a STEM background? Say, example.
I think STEM background is the minimum requirement for our program. Is that correct, Prof? Correct me, I'm wrong. Yeah.
Okay, so maybe we can.
We do evaluate applications even if someone is not from STEM background. Then we will have a short discussion session with them, and if we feel they can will be able to handle this course, then we consider them as well.
Yeah. So the opportunities are always still there. Just reach out and approach.
Yeah.
Approach either Dr. Sachin or
Prof. Jianwen. Yeah.
Okay, so maybe what is the class schedule and timing like?
All these courses are offered in the evening because our program is taken majorly by working individuals. So all these courses are offered in the evening. So the lectures typically start at 6 p.m. or 6 plus p.m. and it will be about 3-hour session with, of course, short breaks in between. So I hope, again, I have answered your question satisfactorily.
Okay. So any questions from the floor? Okay, so does the program cover any research areas?
I did not understand this question clearly, but let me just answer. This program is not by research, right? So just should be clear. So we do have an opportunity, as I mentioned, where you can do a research project with one of the professors that works on the area of your interest, and that research project is spread over a year. That's the opportunity for you to explore, research going on in energy systems.
Okay. So to the person who asked that question, we hope that we have answered it satisfactorily. If not, you are welcome to resubmit another question, and maybe you can elaborate a bit more so we can better understand your question. All right, so next question. Aside from the reduction in CO2 emission, what strategies are the Singapore government applying for CO2 absorption right now and plan for the future?
Well, I would try to answer it from NUS perspective at least, or from our department perspective, what we are doing. I think carbon capture is one of the other thing which the person who has asked this question, Hang In, is not mentioned here. So that is one area. Or waste to energy is another area that our colleagues are working on. So maybe I think these are the two things I will mention in response to this question. But I'm not in a position to answer on the strategies of Singapore government. Extremely sorry for that.
Okay. Okay, so is related work experience mandatory for admission to the program? Will internship experience be counted as work experience?
Well, the related work experience is not mandatory for sure. If you have it, it will be useful, but it is not mandatory at all. So even a fresh graduate with BEng degree or bachelor's degree in any STEM field can apply for the course.
Okay.
What is the distinctive age of this program?
We had a similar question asking about what was the difference, what was the difference between the MEM program and this
Okay.
program. So maybe this is also something
Sure.
similar.
So let me answer this. I think I did flash one slide, right, where we have 3 baskets of courses. One course is completely technical. So as engineers, or with STEM background, I don't want to now specifically use engineer as a word here, right? Because anyone from STEM background can come for our program. So once you are through this program, you would have technical expertise. Along with that, you will have innovation and management related expertise. So it's a multidisciplinary program, focuses on both sides.
Okay, thank you, Dr. Sachin. So maybe we'll have 2 more questions and then we will wrap up this session. Okay, any scholarships or subsidies for the program?
Yes, there are certain subsidies or rebate for Singapore citizens, permanent residents, and NUS alumni. So this information is also available on our website, and this might change every year a little bit. So I don't want to put any numbers or say any numbers now, but there is a fee rebate for Singapore citizens, permanent residents, and NUS alumni.
Okay. So maybe we can have a last question. Is there anybody on the floor who would like to ask a question?
Maybe we can take this and then check whether there's any question.
Sure. Okay. Is there
Is
any
there-
capstone project?
Well, there is no mandatory capstone project for this program, but if you want to do a research project, you can utilize that 1-year course, that project course, and you can explore any area of research that you are interested in. But there is no mandatory capstone project.
Okay. Okay. Thank you, Dr. Sachin.
Is that all?
Okay, yep. So I think with that concludes this session. Let's give Dr. Sachin a round of applause. Thank you very
Thank you.
much for your presentation.
Thank you.
So we would like to invite you to share your views about this event and our presentation.